calculate the velocity of an electron in Bohr's second orbit of lithium atom. Right? Now here students, don't know the velocity of electron in Bohr's first orbit of hydrogen. Had you known that, you would have applied the formula Vn is equal to, this would have been the shortcut, you would have got there. So Vn is equal to V0 into Z divided by M. What is Z over here? Z is the atomic number, and what is N? N is the number of orbit. But we don't know the value of V0. So what we need to do here, we need to start it from the starting. Right? So now we know that in an orbit, or Bohr postulated that only those orbits are possible whose angular momentum mvr is the integral multiple of h upon 2 pi. Right? So from here your velocity will be equal to nh upon 2 pi r, right, or 2 pi r m. Now we know here n, that is the 2, h value, that is the Planck's constant, r the radius we need to calculate, right? So the radius of second orbit of lithium ion will be equal to 0.529 multiplied by, what is the expression for radius? It is n square upon z. So this will give us 0.529 multiplied by, it is the second orbit, that is divided by the atomic number. So what is the atomic number of lithium? It is 3. So after calculation, and this is an angstrom student, so what we are going to do? 10 to the power minus 10. So radius of the second orbit of lithium ion will be equal to 0.529 multiplied by 4 divided by 3 multiplied by 10 to the power minus 10. What we will get here? 0.529 multiplied by 4 divided by 3. So we are getting 0.70 into 10 to the power minus 10. And students, don't use calculators. Try to solve it, try to find out the approximate values. Okay? Now, what will be the velocity equal to? Velocity in second orbit will be equal to n, that is 2. Multiplied by, what is the h, Planck's constant value? It is 6.62 into 10 to the power minus 34, and that has to be divided by what? 2 pi. That is 2 into, what is the value of pi? It is 22 by 7, or it's 3.14. Into the radius, how much we have got? It is 0.70 into 10 to the power minus 10 meters into the mass of electron. What is the mass of electron? It is 9.1 into 10 to the power minus 31 kg. So the velocity of electron in Bohr's second orbit of lithium, it should be iron, right? Ion is equal to, calculate this, it is 2 will get cancelled, right? So 6.62 into 10 to the power 34 minus 34 divided by 3.14 divided by 0.70 divided by 9.1 and divided by 10 to the power 31 minus. So we will get here 3.3, or we can say we are getting here 3.3 into 10 to the power 7 meter per second. So this is our velocity. This question is not right, students. It should be lithium ion. Why? Because Bohr's formula is not applicable to lithium atom. Right? So, what is the velocity we are getting over here? The electron will be moving with the velocity of 3.3 into 10 to the power 3.3 into 10 to the power 5 meter per second. So this would be the velocity of electron in the second orbit of lithium ion.